Until comparatively recently, optical craftsmanship was a highly skilled profession confined to a few trained workers who spent their lifetimes perfecting their skills. But like other industries, the manufacture of optical elements has been mechanized. Automatic precision machines have taken over many of the tasks once done by laborious hand methods. Old-time methods produced optical shapes of high precision, but output was limited because few workers had the necessary skills. Present-day needs call for production in much greater volume than would have been possible under hand production techniques. The purpose of this film is to show some of the techniques which have been successfully used in combining the precision of traditional handicraft methods with the speed and efficiency of modern line production. Physical layout of the plant itself is highly important to successful operation. Departments should be arranged so the work will flow smoothly and logically from the raw stock room to the finished product. Provision should be made for frequent inspection. Physical separation of departments will reduce the danger of damage resulting from mixture of abrasives. Separation of the fine grind and polishing departments reduces the danger of getting abrasives mixed with polishing materials. The polishing room should be air-conditioned if possible. Temperature and humidity control is important in the polishing room. 78 degrees Fahrenheit is about right. Pitch laps work satisfactorily at this temperature and workers are comfortable. With temperature and humidity under control, precise pitch formulae can be worked out in the laboratory using a penetrometer to keep pitch quality uniform. Proper organization of personnel and division of responsibility is essential too. Each worker in each department is responsible through a department head for one definite process or function. To ensure precision workmanship, adequate supervision must be maintained. Every department needs a competent foreman who is thoroughly acquainted with all details of operations under his direction and can give personal supervision to every worker. Close supervision is especially important in training new workers. Line production usually involves the use of many unskilled workers, most of whom have had little or no experience in the optical industry. As in other industries, the secret of successful line production in optical manufacture is division of labor. Each worker is responsible for a definite job and is thoroughly trained to do that job properly. Careful and complete job specifications and records are important too. Here is a job card used by one large optical manufacturer. Detailed instructions are set down for each job. Not much chance for a mistake here. Space is provided at the right of the form for analysis of rejects. This helps keep them at a minimum. Here's a form used in a rough grind inspection department. A sheet is made up for each tray of lenses or prisms, and each inspection is checked off as it is made. In blocking elements for fine grinding and polishing, one of the first steps should be to make up a job card. The card follows the job and data is entered after every operation and every inspection. A well-planned employee training program pays dividends in better workmanship and more efficient production. Frequent departmental training meetings stimulate interest and give workers a better understanding of their jobs. Visual aids have proved their worth in training new workers. A wide variety of 16mm sound films on optical craftsmanship are available for employee training programs. Perhaps no single element is more essential to successful operation of line production than inspection. Inspection at every point from the time the raw stock enters the shop until the finished product leaves the shipping room. Frequent spot inspection makes it possible to check errors when they occur, before a lot of valuable glass has been destroyed by an inaccurately adjusted machine, for example. Every major department should have its own inspection division, where every element can be thoroughly checked before going on to the next operation. The finished element should be put through its paces to see if it will function properly when light is passed through it. Monochromatic light sources such as mercury, sodium, or helium vapors aid in reading test glass. Under this light, Newton's rings appear as dark bands rather than rainbows, and hence can be read more easily and to a greater accuracy. Glass shapes which have failed to pass inspection represent an investment of time and money. Much of this can be salvaged. A regular procedure in every well-organized optical plant is classification of rejects. If a rejected element can be corrected by further processing, it is salvaged. If not, it is scrapped. Prompt and regular analysis of rejects helps in determining the cause of imperfections and preventing their recurrence. This single factor might easily represent the difference between profit and loss in operating a plant. Many production tools used in the optical industry are adaptations of machines designed to handle metal. The vertical surface grinder is an example. Because of its brittle nature, glass requires a great deal more coolant than metal during grinding. Notice the large capacity coolant system on the machine. A heavy and constant flow of coolant must be provided at all times. The results of inadequate coolant can easily be seen by observing elements on a Polaroid viewer. Stresses within the glass show up as cloudy areas, which may lead to pitting during fine grinding or polishing operations. Coolant temperature must be watched. If it were allowed to get too warm, there would be danger of melting the wax holding the optical shapes to the jigs. Temperature should not be allowed to rise above 65 degrees Fahrenheit. During hot weather, ice may be added if necessary. Coolant is important on all machines having abrasive grinding wheels, such as the curvature generator, the prism grooving machine, the rounding machine, and lens edging machines. Diamond bonded wheels are being widely used for the grinding of glass. They cut much more rapidly than other types of abrasive wheels, and if properly adjusted will wear down evenly and require no dressing. Just an occasional touching up with an emery stick to remove accumulated glass particles and other foreign matter. This is how it's done on the curvature generator. The cutting wheel of this machine has a rounded edge, which makes a point contact with the glass. In use, the wheel tends to wear flat. It can be made self-dressing by shifting it to use in grinding a different radius, thus presenting a new surface to the glass. In a shop using more than one machine, this can be accomplished by shifting wheels from one machine to another. Diamond wheels are being used for many operations in the optical industry. Here's one that speeds up the grinding of tops and corners. It's an adaptation of a common bench grinder. One end is fitted with a jig to hold the prisms in position for grinding the corners. First one corner, then the other. The other end is fitted for grinding the tops. Lots faster and easier than mounting them on a plano plate. Diamond wheels can be used to speed up the edging of lenses. With a peripheral speed of 3,400 feet a minute, the machine will edge the largest lens ground in the average shop while the operator is centering the next one. Notice the lateral movement of the wheel. It should be adjusted so that the edge of the lens moves just past the edge of the wheel at each end of the stroke. This will wear the wheel evenly. Diamond grit has also been adapted to the tool for beveling the edges. This device is faster and easier to use than the conventional cup tool and emery. Scraping the wax away from the centering chuck subjects the chuck to wear from the scraping tool. Brass chucks will gradually wear away, exposing the lens surface to danger of scratches. On machines being used continuously for the same size of lens, this can be overcome by using hardened steel chucks. They must be trued up after being put on the machine, so they are not readily interchangeable. Glass chips easily and must be handled with care.